Welcome to week 4. For those of you who are doing all these problems, a big thank you. I know this is a lot of work. This is really hard and you're unsupported and on your own coding, but I've noticed some of you are really doing a great job keeping up. Keep up the fight. The problem for week 4, again, is an A and a B part problem, but it's going to be similar to your second free response question, which is going to be 35% of your grade, which is going to be methods and control structures. So they're going to be asking you a problem, and the example they gave was question 2, which is the example they gave was this sample question. And here's the sample question. It involves using check digits, which are used to detect if an error has occurred when a number is entered or transmitted electronically. And there's some code provided to you that you do have to spend a few minutes absorbing. You're going to be implementing this part A, the get check, and you're going to be implementing the part B to see if a number is valid and just returning a simple true or false. There are two methods that you're going to use for that. There is a get number of digits method and a get a digit method, and you kind of have to absorb how those work and how you'll use those in order to solve the problem. And I've written those for you in the replit though, so that you can use the code that is fully functional. Absorbing the problem, again, was for me the hardest part of the problem. And what it's asking you to do is take a digit that's up to 6 digits long, and you multiply the first digit by 7, the second digit by 6, the third digit by 5, so on, all the way through, and then you add those numbers up. And then when you add those numbers up, you're just returning one digit, only the digit in the tens place. So if, for example, for the number 283415, you would take the 2 times that 7, because you're multiplying the first digit by 7. Then the next digit, 8, you're multiplying by 6. 3, which is the next digit, and you're multiplying it by 5, and so on. And then you add those up and you get that 106. Then you only want the rightmost digit, or the 6. So absorbing the problem is the toughest part. And once you absorb the problem, you'll see the things you need. And actually implementing this nth digit is quite a bit of work and requires some parsing or some casting and parsing, and it's kind of a complicated situation. But you give it a number and then you give it a digit and it will return the value of that digit. Now they've kind of shown you how those methods work. So for a get number of digits, for the first example, you get back 6 because it has 6 digits. For example, if you did the 283415 and you asked for digit 1, you'd get the number 2 because it's the first digit. Notice it's counting, or it's gathering digits left to right. So that's kind of important to know. If you ask for digit 5, it's going to go 1, 2, 3, 4, 5. Notice it's not zero-based indexing. So all that is important to know, and absorbing how those methods work is going to be really, really critical in your work to solve the problem. So let's solve the problem together. I'm going to do a walkthrough and show you how I would solve part A. Now, the first thing I want to do is I want to make sure I get what I call my free points. Remember, you get a free point just for returning the right data type. Since this method is asking you to return an int, I want to make sure I return an int. So I'm going to make an int result. I'm going to set it to 0, kind of as the default starting point, and I'm going to return that result. Now, no matter what, I get that free point. Sorry about all that. I get that free point just for returning the right data type. Now, this is screaming of a for loop, right? And I got to admit, when I just wrote this problem out without running it through the compiler the first time, I was, oh Bob, I was off by 1. So this starting I at 1 was an evolution from my original thinking, but it makes sense since the digits are counting from 1 through the length. So when you're in that pattern, you're going to want to be less than or equal to and I'm going to use that the get number of digits for num, and then I'm going I plus plus, and I'm going to go from 1 to the number of digits. So for digit 6, I get that 6th digit. And then I'm going to go through that loop and get those digits. Now, the other thing that I need to do is I need to start at that 7. And each step through the loop, I need to go down by 1. So I start at 7, then I multiply the digit by 7, then by 6, then by 5, and so on. So before the loop even starts, I'm going to declare a multiply by. And I'm going to set it to that value of 7. And it's going to be important. Somewhere near at the bottom of the loop, I'm going to want to decrement or decrease that 7 to the 1 less than the value it's currently on. Now I'm going to take my result, and I'm going to have it equal to my result plus the value it asks for, which is the digit in the first place, then the digit in the second place, etc., times my current multiply by. So to do that, I'm going to get digit. I'm going to get the digit of num at I. So I'm going to get that digit, and then I'm going to multiply it by my multiply by. And then keep going through the loop. Each time my result is going to get bigger by the digit I'm on times that multiply by. Now if I were to run this, the result I would get would be this huge 161. Well, the reason it's way too big and it's supposed to be 106 is because I forgot to reduce my multiply by. So I can easily fix that by taking my multiply by, and I can go like that, or I could go like that, or even better, or even clearer, I can go multiply by minus 1, whichever you prefer. All those should return that same result, so I should now get 106. But it says it's expecting just a 6, not a 106. Well, that's because I need the modulus. Or I just need the digit in the ones place, which is a classic modulus operation. So I'm going to return the result, and I'm just going to say, hey, give me the digit in the ones place, which is a modulus 10 operation. So when I run it this way, boom, I get the expected results. Again, this was a tricky problem, and I'm not sure if I would have been able to solve it perfectly in the 15 minutes allowed. I'm pretty sure I would have been off by 1 in my solution, and I think I might have lost some points for that, but the overall flow of the problem is pretty good. It's that there's a couple of tricks in there, and I wish you the best of luck with this part. This time, in my opinion, part A is trickier than part B.